Okay, this is your second review of Chapter 3 on Pythagorean relationships. Your exam is in 2 weeks from tomorrow. Oh, 2 weeks from today, actually, or a week and 6 days. I think it's on Monday. So we're building up towards that with our Pythagorean review. The first questions are true and false, and the first question says the number 60 has four prime factors, true or false. So the first thing I want to do is write the number 60, and I want to break it down into the product of just prime numbers. I'm going to break it into 6 and 10. You can break it up into 2 and 30. You could do 5 and 12 if you wanted to. I'm doing 6 and 10. Neither one of these are prime, but I could break 6 down into the prime factors of 2 and 3, and I could break 10 down into 2 and 5. And neither one of those numbers can go past that. So when we look at the prime factors, there are 4 prime factors, and therefore your answer number 1 is true. There are 4 prime factors for the number 60. Question 2 says if a square has a perimeter of 40 meters, so I'm going to draw a square, and we know the square sides are all equal, and if its perimeter is 40 meters, then that must mean that each of these sides is 10 meters, because that's the only way you can get a square to have a perimeter of 40 meters. And if that's true, then side squared would be the area, or 10 squared, which means its area would be 100 meters squared, which makes this a true statement. Question 3, 196 is a perfect square. Well, there's 2 ways to do it. Obviously, you can take your calculator and go 196, and if its square root is a whole number, or a terminating decimal, it's a perfect square. In this case, the square root of 196 is 14, so we know that it's true. Another way you could do that without a calculator is that you could prime factorize it. And the only problem is this would be 2 and 98. Let's put a 9 there. This can break down into 2 and 45 plus 3 is 49. And this can break down into 7 and 7. And then when you rearrange them, you can arrange them in 2 equal groups of 2 and 7, 2 and 7, which means 14 is the square root, or it is a perfect square. Question 4, a triangle with sides of 4 centimeters, 5 centimeters, and 6 centimeters must be a right triangle. So if I was to draw a triangle and put 4, 5, and 6 here, 6 being obviously the hypotenuse, it can't be a right triangle because it does not follow Pythagoras. And if I was to attach squares under here, this would have an area of 16. This would have an area of 25. And if it was a right triangle, this should have an area of 41. But clearly it doesn't. So therefore, it is false. It is not true. Question 6 or 5 is your last true-false question. It says a triangle with 3 squares attached to the sides as shown. 2 of the squares have an areas of 25 and 24 meters squared. The third side length could be 7 meters. Well, this is kind of tricky because really, if I think about this question, I'm going to clone it. If I think about this question, there are 2 situations that it could be. We know that this hypotenuse has to be the largest area, so it technically, this is one possibility that the arrangement could be. But the other possibility is this being 24 and this being 25. These are 2 scenarios that it could be. And if this was the case, this area would have to be 1 meter squared, which would make the side length of that third side 1. That's one possibility. The other one, this would have 24 and 25. This area would be 49 meters squared, which would mean that this missing side length is 7 meters, and therefore that is possible that the third side could be 7 if this was the arrangement. If this was the arrangement where 25 was the area of the square attached to the hypotenuse and 24 meters squared was attached to the leg, then the missing side length would be 1 in this scenario, but this is a possibility, so therefore it's true. It is possible to have a side length of 7. Question 6 is a multiple choice. It says, what is a whole number whose square root is between 9 and 10? So if I think about the square root of 81 as being 9 and the square root of 100 as being 10, any number between 81 and 100, if I was to put that in a calculator, any number between 81 and 100 would have a square root between 9 and 10, and the only one of these that fits that is B. So therefore the answer is B. And if I wanted to double check my work in the exam, I could put what is the square root of 91? It's 9.5-ish, which is a square root between 9 and 10. So therefore your answer is B. Question 7, what is a good estimation for x? Since this number here is 5 and this number here is 6, then x looks like it's right in the middle of it, which means a good estimation would be B. 5.5 would be a good estimation for the value of x. Question 8, what is a good estimation for, or what is the area of the third square? Again, this is probably one of the easiest questions on the test because really we know that the sum, this area plus this area, the area of the squares attached to the legs of a right triangle have to equal the area of the square attached to the hypotenuse. So 18 plus what is 25? If I was doing it on paper, I'd actually subtract those. I'd figure out that it's 7. So therefore 7 meters squared would be the area of the missing square, which is your answer. The area of the square attached to the third side, or the missing side, is 7 square meters. Question 9, what is an approximation for the length of that? Well, we just had the same question again. This was 7 meters squared, which means that the length of the side of a square whose area is 7 meters squared would be the square root of 7. That's the answer for the exact measure of x. But the approximate value of x for the square root of 7, if I wanted to do it without a calculator, I could do the square root of 4 is 2, square root of 9 is 3, square root of 7 would be here somewhere, so 2.6 would be a good estimation. But since you were allowed to use calculators, you can just take 7 and press the square root sign, and 2.6 is still 2.6, 2.7, 2.8. Those are all valid estimations, depending on if you used a calculator or not. Even 2.5 would be fine. Question number 10 is what is the value of x? So we have the area of this square is 119 meters squared. The area of this square is 25. The area of the third square, or the one attached to the hypotenuse, is sum of those, which would be 144 meters squared. Therefore, the square root of 144 would be the side length, and therefore the hypotenuse length for the value of x is 12 meters. The square root of 144. Question 11, use prime factorization. Prove that 100 is a perfect square. So on your test, you have to have something that looks like a prime factorization tree. I'm going to do the old standard 2 and 50. 2 is prime, 50 is not. 5 and 10. 5 is prime, 10 is not. So we have, as a prime factorization tree, the product of 2 and 5 and 2 and 5 is 100, and therefore 10 times 10 is another way to say 100, and therefore it is a perfect square. And how many prime factors does it have? It has 1, 2, 3, 4. So 2 parts to that question. First part, is it a perfect square? Yes. And second part, how many prime factors have it? It has 4. Question 12, what's the approximate square root of 80? Square root of 81 is 9. Square root of 64 is 8. Square root of 80 would be somewhere around here, which would approximately be 8.9-ish. You probably shouldn't dip down to 8.8. That's a little bit too poor of an estimation. So probably the only estimation using a number line would be 8.9, maybe 8.8. If a square has an area of 36 meters squared, so its area is 36 meters squared, then we know that its side length must be the square, or no, not squared, must be 6 meters. And therefore, since it's a square, all of them are 6 meters. And the perimeter would be 6 plus 6 plus 6 plus 6, or 6 times 4. And therefore, the perimeter is 24 meters. Question 14. A rectangle has sides of 9 meters and 5 meters. What is the length of its diagonal? All right, so if we think about this in terms of not a rectangle, but rather a right triangle, we see that we have a right triangle here with 2 legs known and a hypotenuse is not known. I'm going to use my formula this time. A squared plus B squared equals C squared. A and B are always the legs that make up this 90-degree angle right here. So 9 squared plus 5 squared will equal x squared, or 81 plus 25 will equal x squared, or 106 will equal x squared. In order to isolate for x when it's x squared, you're going to square root both sides. X will equal the square root of 106, which is probably 10.2 or 10.3. We'll take our calculator, 106, and press the square root. It's 10.3. So x is approximately, the diagonal length is approximately 10.3 meters, or 10.2 meters, or 10.1, or 10.4, whatever. If you used your estimation without a calculator, all those are valid answers. And the last question says, what is the approximate sum of both the area and the perimeter of this triangle? So the perimeter would be that red triangle there, and the area would be using this height here. So the first thing we do is find out the perimeter. This is 3, this is 4, and we don't know this here. But if we look at that as a Pythagorean triple, we know that this must be 5 centimeters. And we can take it in isolation and look at this and say, well, this is 3, so this area would be 9 meters squared. This would be 16 meters squared. This would be 25 meters squared, which would make the side length of that one, that missing one that we don't know, 5 meters. Okay? Now that we know that, we don't know all of the sides of our triangle yet. We still don't know this distance here. Right? So, but if we take it as a triangle here, I slide this, oh, no, I want to slide the black one down. If I bring that black one down here, I got 3 centimeters here, and I got the square root of 45 centimeters here. So if I attach legs to it, or squares to the legs, excuse me, and the hypotenuse, this would be 9 centimeters squared. This one would be 45 centimeters squared, because the square root of it would be the side length. And therefore, this must be 36 centimeters squared as an area. And if we know that's its area, then if 36 centimeters squared is the area of the square attached to that missing part down here, it takes forever to erase, this one must be 6 centimeters. Okay. Now we have all the information we need. In order to get the perimeter, I'm going to add up this, which is 6 plus 4, 10, plus 5 is 15, and the square root of 45 is approximately 6.7. So we have 15 plus 6.7. The perimeter is 21.7 centimeters. 21.7 centimeters. And the area would be 10 times 3, which is 30, divided by 2. The area would be half of, so what did I say it was again? 10, 30, 15. It'd be 15 centimeters squared. So therefore, the sum of those two numbers, the one we're looking for, is 36.7, or 36.7. We don't need that centimeters or centimeters squared, because you're just looking for the sum of the two numbers. So if you had this one, you get a point. If you had this one, you get a point. And if you had both of them, you get the 2 points for having the sum correctly. So you get 2 points for this question altogether. Oh, is there another question? No, that's it.